When students hear the terms weak acid or weak base, they often think that we're talking about how concentrated the acid or base is, and this isn't true at all. The strength of an acid or a base is actually referring to its amount of dissociation. You recall that acids are electrolytes and they dissociate to produce protons in water. Strong acids are those that dissociate completely. Now, I've drawn the more correct way of showing hydrochloric acid ionizing in water. And so here is hydrochloric acid, and water reacts with it and takes a proton off to make hydronium ion and the chloride. But I'm going to go to the simplified version. It's a lot easier to look at and see the concept better. Hydrochloric acid, when put in water, will make a proton and a chloride, and of course the proton's picked up by water. Notice there is a single arrow. This indicates that the reaction went to completion. None of this is left. When it dissolved, every single one of them broke apart and made protons and chlorides in solution. So you can't find this in solution. It's completely dissociated. However, when you have a weak acids partially dissociate. Again, I'm giving you both reactions. The one that's showing what's really happening, acetic acid giving a proton to water, and you make the hydronium ion and acetate. But again, let's look at this simplified version to make it easier to grasp the concept. Here is acetic acid, and what does it do in water? It breaks off a proton, which water picks up, and it makes acetate. But look at the double arrows. The double arrow indicates there's a forward reaction and there's a reverse reaction. So when I put acetic acid in water, some of it breaks apart to protons and acetate, but a lot of it does not. And of course, we have a steady state of it breaking apart and going back together again. But a huge portion of the acetic acid remains stuck together in solution. So the key thing to note here is that you have equilibrium arrows, and the equilibrium arrows indicate that it's a weak acid. Strong bases are electrolytes that dissociate completely. We recall that bases are electrolytes and they make ions in solution. What do? They make hydroxide in solution. Here is sodium hydroxide, a strong base. What does it do? It breaks apart to sodium and hydroxide in water. If it's strong, you get 100% of it breaking apart. The arrow indicates none of this was left behind. Only sodium and hydroxide are found in solution. No, none of them stuck together. If you have a weak base, like a weak acid, it partially dissociates. Here is ammonium reacting with water, and when it reacts with water, it pulls a proton off it to make, ammonia reacting with water. It pulls a proton off the water to make ammonium, and then what's left over is hydroxide. So it produces hydroxide in water. That's a definition of a base. But we have a double arrow. The double arrow indicates that ammonium and hydroxide recombine to make ammonia and water. So only small amounts of this are made, and a lot of this is floating around in the water solution. Again, equilibrium arrows indicate a weak base. So to summarize, acids and bases can be either strong or weak. The majority of acids and bases are weak. There's only probably about 5 or 6 strong acids and maybe 5 or 6 strong bases. When we talk about strength, we're talking about the degree of dissociation, and it is not a measure of concentration. Strong acids and bases completely dissociate. Weak acids and bases partially dissociate, and they are in equilibrium between the intact and the dissociated. Here's a picture of it. This is a weak acid in water. Notice it's weak because the majority of the protons are stuck to the acid. Only a small amount has dissociated. If you have a strong acid in water, all of it has separated, and you have just ions in solution, no intact acid.